And thanks for the introduction, and thanks everyone for watching. So I'll give a quick reminder about what is CosmWasm ICA controller. This is an infrastructure contract that allows any CosmWasm chain to create and control interchain accounts on other chains. It's already being used by some teams, and including some of the teams that are in this funding round, and adoption is growing by day. It lets you do things that were impossible previously or required chain developers' intervention. Since this is an infrastructure contract, I'll demo an application I built using it on Injective to demonstrate its power, instead of just showing you that it passes tests or on the client side. So I built a front-end application that I'll be demoing today. So I created a documentation website. If you want to learn more about the contract and how it works, then there's a nice documentation. You can see the link here, and I'll share it in the future. So let's get into the actual application. This application is called Tokenized Interchain Accounts, where users are allowed to mint NFTs, where each NFT controls an account on a counterparty chain. And these NFTs can be traded, so you can essentially trade accounts. And this allows for many possibilities in DeFi, such as maybe selling your airdrop before it's airdropped, or trading, like, for example, abstract SDK, I was thinking about selling ETFs as accounts. And there's many other things you can do when accounts are actually included in DeFi. Now, for this application to run, it's an IBC application, right? So there has to be a relayer running in the background, and I'm running my own relayer in the background, as you can see. Okay, so now I will actually demo the application. As you can see, I've already created 2 NFTs on Injective that control accounts on other chains. So what I will do now is I'm actually going to create a new interchain account to show you how easy it is. So I just click mint an interchain account. On Injective, you just sign the transaction, and then the minting process has begun. As you can see, it says minting NFTs. It will take about a minute or two. Number one, it's because the relayer has to relay messages and it takes time. And number two is because this is on a testnet, it takes longer for the gRPC endpoints have lower reliability. So it takes a little bit longer than it should. So let's just wait for this to complete and create a new interchain account. And I chose these names for the NFTs, but you could choose anything. You can see that in the background, the channel opening handshake is happening. There's like channel open acknowledgement, so it's happening in the background. Okay, now the NFT is minted. You can see that now there's a interchain account address on the counterparty chain. In this case, it's CosmWasm testnet. The reason why I chose CosmWasm testnet is to show the power of the contract, because CosmWasm testnet doesn't even have smart contracts. So to actually control accounts there, you really need to do native IBC magic. And you can see that if you just go to mint scan, for some reason I have bad connection apparently, but you can see that an account is created. Currently it has no balance, and we can just fix that. So let's just send some balance to this account. And the way I'll do that is I already have a funded account already, and I'm just going to send some atom to it from this account. So maybe I'll just do a send message on the other chain, which is this address. I'm going to send to the new address, and I'm going to send, let's say, 2 atoms. So I know the UX is not ideal because I'm putting a bunch of zeros, but again, this is something the front-end developers can improve. I just added this to demonstrate that it is possible. So I'm just so there should be 6 zeros, just let's verify it, that's right. And then we just broadcast to send it to atoms. Okay, as you can see, that message is sent. It's going to take a while again because the relayer has to relay the messages and an acknowledgement has to be received. If you go look at this interchain account mint scan, we will see that it has some balance. Yeah, you can see that it initially has 2.89 atom. After this transaction completes, it should have 0.89 atom because we are sending 2 of them to the new interchain account. So let's just wait a little bit for this transaction to complete. This transaction will actually be executed before there's a check mark here. And the reason is that a packet can be received on the other chain, but this only turns into a check mark after the acknowledgement of that packet is received on Injective. Yes, so let's just refresh this page and see if it's actually executed. You can see that it's already executed, 0.89. And if we go back to the application, now this is a check mark because its acknowledgement has reached back to injector. Okay, so now we've created a new account and we have funded it. And we can also refresh this to see that now it has not 0 atoms, but 2 atoms. Yes, now it has 2 atoms. Well, because this is an NFT, this allows us to do something interesting. We can just send this account to another user. So here I have another wallet that I already opened, which is this wallet. And I'm going to send my NFT to this wallet. So recipient address, let's just put this address. This is my second injector wallet. I'm just going to transfer the NFT. Sign. And you can see that the NFT is now gone from my profile. And let's just go to this account to see that the NFT has arrived there. Again, all of these applications were previously impossible unless you use some very specific chain bindings with like some chain developer intervention like Neutron. And those applications you wrote there wouldn't be able to work in any other chain. So this allows you to build this kind of interchain applications in every chain. And that's why there's so many adopters. And you can see that this token has arrived to my second account. If we go in here, again, it's the same interchain account. And to demonstrate that these accounts are really capable of doing anything, they can even send Wasm messages. But because it's Cosmos Hub, there's no way to send Wasm messages because there's no Wasm. But to demonstrate that these are really able to do very powerful things, I'm going to send 2 messages in one transaction, a delegate message and also an IBC message. So I'm going to do an IBC transfer with an interchain account. So we are using IBC 2 times here, just to demonstrate that these contracts are really capable of doing a lot of complicated things. So if we go to Cosmos Hub testnet and go to validators, let's just delegate some tokens to this validator. There's the validator address, so we just copy it and then put this as the validator address. Let's say I want to validate 0.5 atoms, so let's just do, this should be 5 zeros. Okay, and the denomination is U atom. Okay, so now it will first delegate, and then it's going to do an IBC transfer. And what I want to do is I want to transfer myself some atom to my injective account from that chain. So in this case, again, this is my injective account, the second injective wallet. So let's just use this. So let's just use this here. And then there's a transfer channel that we are going to relay the message from. And that transfer channel is, channel 3602. So this is the transfer channel that I'm going to use to send the atom. And let's say the amount I want to send is, let's say 0.1 atom. And a U atom. Okay. So when you actually add these into the same transaction, if either of these messages fail, then the entire transaction will fail. So you could actually build applications that build messages that rely on the previous one. So I'm just showing you that you can send messages atomically. And let's just, you can add a memo and a timeout. We are not going to do that. We just use the defaults for these. And we are going to broadcast this now. Okay, looks good. Okay, so yeah, you can see that there's a multi-message sent. So now we just have to wait until this message is verified and the tokens arrive here. You can see that I've already done some IBC transfers with my wallet in the past, so there's some IBC denomination here. We expect this to be another IBC denomination, so not this one. So after this is completed, I should get another IBC token here, which corresponds to the amount of atom I sent. In which case it was 10,000. I think it was 10,000. 10,000 U atom, which is like 0.1 atom. So we just need to wait until it confirms. It's going to take a little bit longer because this is doing 2 things. One is this packet has to be received, and second, the transfer packet has to be received from Cosmos Hub to here. Okay, so it seems like for some reason this has failed. I'm guessing the reason is So that means I've actually like put some incorrect parameters in the message. So maybe I counted the zeros incorrectly, or maybe the delegation message has failed because I didn't have enough atom. So let me. So I'm gonna do it again. So just because I probably just put the addresses incorrectly. Yeah. So it has still 2 atoms. Okay. So the IBC transfer is the interesting one. So I want to do this specifically. It's 5 zeros. Good U atom. But this is actually a good demonstration where if you were using other like interchain accounts, like if you're trying to use it natively, which is almost impossible due to some reasons, you wouldn't even know that why the message errored or if it's even errored. So here we can see that I definitely know that there was something wrong with the structure of my message. So this is not to say that there is some unrecoverable error. This is something very expected in the interchain account protocol. That like you put something wrong in the fields. So let's try one more time. So let's copy the address, which is this channel ID again, channel 3602. Delegate. Maybe there is something wrong with delegate. So maybe I think I have enough time, so I can just put the delegate message as well. I don't see anything wrong with that. Again, where is the earth validator? Here. The validator address is this, just making sure everything looks right. Okay, so maybe there's a minimum amount of validation, so let's just validate 1 atom. So 6 zeros, 1, 2, 3, 4, 5, 6. U atom. Okay, and if this fails, then I will that means I don't know something about delegation, and then I'll just send a transfer message. This looks good to me. Broadcast. All right, let's try again. While this is going on, I can talk a little bit about what this channel status means. In interchain accounts, it's possible for a channel to close when there is a timeout because it's an ordered channel. And this interface also provides you the ability to immediately reopen the channel in case it was closed. Yeah. So let's see what's happening on the relayer side while this is happening. Yeah, everything seems fine, I think. So we just have to wait. Yeah, it's seeing the correct channel. Wait. Oh yeah, I think that's right. Okay. Yeah. Okay. Now it succeeded. So yeah, that really means that I actually entered a field incorrectly in the previous message. We can refresh this page, see that the atom amount has decreased. You can see that the atom is now the expected amount, which is 0.9. And we see that we have delegated 1 atom to the earth validator. And there should be an IBC tokens in my second account. You can see this was the previous thing. Now, if I refresh, I should see more. And yeah, you can see now there are two ones, and there's 100,000 U atom, which is what I sent. So this was just to demonstrate the power of the protocol, power of this contract. You could build much more applications with it. You could build the entirety of Stride as a smart contract in any CosmWasm chain. And like Abstract SDK, you can use it for an abstract account management system. And the possibilities are really just your imagination at this point. So thanks everyone for watching, and thank you DoraHacks for allowing me to demo my application.